Hello, Math 119 students. Well, in Chapter 5, we learned the Poisson distribution, the binomial distribution, and the hypergeometric distribution. So here we have page 301 in the Hawkes textbook. And in these problems, you have to recognize which distribution to use. And then, once you do that, then you can solve the problem. So the book has the answers for the odd-numbered problems in it at the back. So I thought I would do the even-numbered problems and make a video on it. So here we go. So I'll start with number 14. We'll do 14, 16, and 18. So first thing is you have to read the problem and be able to recognize which distribution to use. So here, let's go over the distributions first. Here I have the probability formulas for each of the three distributions. For the binomial, we have n trials, x is a number of successes, p is the success probability. So here's the probability formula. For the Poisson distribution, we have an interval, generally a time interval. The mean number of occurrences in the time interval is lambda. So the formula is given here. The probability of x occurrences in the time interval will be given by this formula. And then with a hypergeometric distribution, you have objects and objects consisting of two types, such as you may have marbles with two different colors. So capital N is the total number of marbles you have. Little n is the number of marbles you're selecting. So you have all these marbles consisting of two types, and you select a subset of them, a certain number of them. And then K would be the number of marbles of type 1. Let's say red marbles. N minus K would be the number of marbles of type 2. Let's say green marbles. Okay, then X, out of the selection of N, it will ask for the probability that you select x of type 1 and n minus x of type 2. Okay, so let's look at number 14 and figure out what distribution to use, and then figure out how to solve it. So in this one we have 250 tax returns within a given region. 15 have serious errors unknown to the IRS. If an IRS agent randomly selects 25 of the 250 tax returns on which to perform an audit, what is the probability 3 of these tax returns will have serious errors? Okay. I'm going to cover up the answers for now. So, this one would be hypergeometric because we have a set number of objects, in this case tax returns would be 250, and then we have 15 have errors, and that means 235 do not have errors, and we're selecting 25. And then we want to find the probability that 3 have errors, so that must mean that 22 do not have errors. Okay, so the way we'll use, actually I'm not even going to use this formula here. If you have 250 objects or 250 returns and you're selecting 25, how many ways can you select 25 tax returns from a total of 250? That's your denominator. That would be 250 C 25. All right, so this is the number of ways you can select 25 tax returns from the total. Now the tax returns consist of 15 with errors and 235 that do not have errors. Right, so the 15 these are the ones that have the errors. These are the ones that do not have the errors. And so of these 25 that I'm going to select, it asks for the probability. I select 3 with errors, and that must mean that I select 22 without the errors. So let's look at what this means. The denominator tells us the total number of ways we can select 25 tax returns from 250. The 15C3 tells us how many ways we can select 3 tax returns from 15 that have errors. And then the 235C22 tells us how many ways we can select 22 tax returns without errors from 235. So we'll plug this into the calculator. Hit the math button. So 15C3 will multiply by 235C22. So I have 15C3 multiplied by 235C22. I'm going to divide by 250C25. Okay, so there's what I have. It comes out to be 0.1292. So now we can check the answer. It matches 0.1292. And you can see 250C25, that's the denominator. That's a 17-digit number. So you have some fairly big numbers here if you write it as a fraction. Next problem, number 16. Okay, 16, let's read the problem. It says, according to records from a large public university, 85% of students who graduate from the university successfully find employment in their chosen field within 6 months of graduation. What is the probability that 8 randomly selected students who have graduated from this university, at least 5 of them find employment in their chosen field within 6 months? Okay? So, in this case, we have a set number of trials because 8 students, each student would be a trial, and the success probability would be 0.85. So this would be a binomial distribution. So we have n equals 8, p equals 0.85. And so we want to find the probability that we have at least 5. The probability of 5 or more. So this would be P P of 5 all the way through P of 8. However, we can use the binom CDF command and use the complement. The complement of x being greater than or equal to 5 is x being less than or equal to 4. Now we can use binom CDF. So binom CDF of 4. So we have 8 trials. Binomial CDF of 4 equals 0.0214. And that will give us 0.9786. Which is correct, 0.9786. And let's see what the answer is on the answer sheet. 0.9786. So the last problem, number 18. So number 18 says, a child welfare office receives an average of 5 reports of child abuse per day. What is the probability that the child welfare office will have a slow day and receive no more than 2 reports? Okay. It looks like we're dealing with a time interval, which would be 1 day. So when we have a time interval and a certain number of occurrences, this will be a Poisson distribution. Okay, so the mean, since the probability asks that the time interval is 1 day and the mean is in terms of 1 day, then lambda will equal 5. So we have a Poisson where the time interval is 1 day and lambda, the mean, would be 5. So the formula this would be the probability formula. We want to find the probability of 2 or less. So you could calculate P of 2, P of 1, and P of 0 using this formula. And then add the numbers together. Add the 3 values together. That should give you the right answer. The easier way is we can use Poisson CDF. That will give us the cumulative probability of 2. So Poisson, let's do it that way. Poisson CDF is in this list below the binomial PDF and CDF. So mu is the mean. The calculator uses mu. Our book uses lambda. That would be 5. X will be 2. And this should give us the right answer, 0.1247. So there's a good example for a Poisson problem. And that's the answer is correct, 0.1247. So if you have questions, if you try any of these other problems and you have questions, please contact me. I can help you with them. And the answer is in the back to the odd numbered problems. But that's all for this video.